In this lecture module, we want to turn our attention to beginning the process of increasing the scope and power of our categorical logic. We'll start by increasing the number of arguments that we can evaluate for validity or invalidity. Recall that in our first lecture module, we introduced our Venn diagram technique for evaluating the validity or invalidity of direct inferences. That is, inferences with a single standard form categorical statement or its denial as a premise, and a single standard form categorical statement or its denial as a conclusion. We learned how to do that under the Boolean interpretation. We now want to modify that effective decision procedure so that we can evaluate arguments under both the Boolean interpretation and the Aristotelian interpretation, thereby increasing the number of valid argument forms that we can recognize within our categorical logic and utilizing our effective decision procedure. To do that, we'll start by talking about how we have to change the way that we represent what minimally has to be true in order for a standard form categorical statement to be true under the Aristotelian interpretation. We'll only need to deploy these modifications of our standard Venn diagram representations when we need to evaluate an argument specifically for Aristotelian validity. And even then, we'll only have to deploy these modifications for the subject class of our premise diagram. So the number of alterations that we'll have to make in order to generalize our effective decision procedure will really be relatively small. We'll also have to learn how to modify our Venn diagrams to symbolize what minimally has to be true in order for the denial of a standard form categorical statement to be true. But we'll only again have to do that for our subject class in our premise diagram. Finally, we'll have to introduce the notion of the existential fallacy. The Aristotelian interpretation assumes that classes have at least one member. Therefore, if we evaluate an argument using our modified Venn diagram technique, and it turns out to be valid in Aristotelian logic, but one of the classes does not have a member, then that argument commits the existential fallacy. We'll want to understand the existential fallacy and learn when we need to incorporate an evaluation of whether or not an argument commits the existential fallacy into our effective decision procedure. Finally, we'll spell out that mechanical process for our effective decision procedure such that if we just follow it in a step-by-step fashion, we will always get the answer about the validity or invalidity of these direct inferences in both the Boolean and Aristotelian interpretation, and that answer will always be right. We'll end the lecture by expanding the scope of our logic again, this time by increasing the representational capacity of our logic through the adoption of various translation heuristics. Recall that our logic is intentionally simplified. It is very, very simple. It only has 4 standard form categorical statements together with their denials. The English language is, of course, much more complex and variable. The world itself is also much more complex and variable. So in order to maximize the representational and evaluative capacity of our language, we'll need to formulate a set of fallible strategies for translating this more complex and variable world and language into this simple formal system in a way that captures the significant logical features of that language and world within the simple system. Only by doing this do we maximize that trade-off between the ease of learning and use that our simplicity gains us and the expressive power that we gain through translating as much of the world as possible into that simple formal system by adopting strategies for apt translation. Recall that the Boolean interpretation introduced 2 instances of one kind of necessary logical relationship holding between these 4 standard form categorical statements. The contradictory relationship holds between the universal affirmative type A statement and the particular negative type O statement, and the universal negative type E statement and the particular affirmative type I statement. As a result, a universal affirmative will always have the opposite truth value of a particular negative. If the A statement is true, the O statement is false. If the O statement is true, the A statement is false. And that same relation holds between the universal negative and the particular affirmative. But that was the only necessary relationship that held under the Boolean interpretation. The Aristotelian interpretation, with that additional specification that classes have to have at least one member or properties have to have at least one instance, we get an additional 3 different kinds of necessary logical relationships holding between the individual standard form categorical statements. So between the universal statements, we get the contrary relation, such that at least one of the universal statements will have to be false. They cannot both be true. And between our particular statements, at least one of those particular statements has to be true. They cannot both be false. The relationships between universal and particular affirmative and negative statements is a little more complicated. It's called the subalternation relation, and it asserts that if a universal affirmative statement is true, the particular affirmative statement is true, and if the particular affirmative statement is false, the universal affirmative statement must also be false. Truth flows down, falsity rises up. And that subalternation relation holds between A and I, and also between E and O, the universal negative and the particular negative. So in order to leverage all of these additional necessary relationships between the individual standard form categorical statements of our logic, we'll need to modify our effective decision procedure in order to capture that Aristotelian assumption. Recall that our effective decision procedure began with that definition of validity. An argument is valid if and only if it has a structure such that whenever the premises are true, the conclusion must also be true. We designed our Venn diagram technique to test whether the argument we're considering violates or satisfies that definition. So we would graphically depict what must be true if our conclusion is true in the conclusion diagram, and we would graphically depict what must be true if our premise or premises are true in the premise diagram. We then compare those two diagrams. If the conditions in the conclusion diagram are also in our premise diagram, then it's impossible to make the premises true without also making the conclusion true. The argument satisfies the definition and is valid in Boolean logic. If the conditions in the conclusion diagram are not also in our premise diagram, the argument is invalid in Boolean logic as it violates our definition of validity. In order to modify our Venn diagram technique to capture Aristotelian logic, we have to modify our premise diagram. We have to make sure that the subject class of our premise diagram has at least one member. That is, it satisfies that Aristotelian assumption. Why just the subject class? Why just the premise diagram? It turns out that because our subject classes are being included in or excluded from our predicate classes, that only the subject class matters, and only the premise being altered will matter in terms of whether or not the argument is valid or invalid. Once we've modified our diagram, then we compare the new diagram, the newly modified premise diagram, to the conclusion diagram. If the conditions in the conclusion diagram are not in our premise diagram, then the argument is invalid in both logics. If the conditions in the conclusion diagram are also in our premise diagram, then we have to ask, does that class, the subject class in our premise diagram, does it have a member? If it does have a member, it satisfies that Aristotelian assumption, and so the argument is valid in Aristotelian logic. If that class does not have a member, then it commits the existential fallacy. It assumes that the class has a member, that something exists that satisfies that property, when in fact it does not. In the next lecture module, we'll go through the details of how we have to alter our effective decision procedure to make it into this general effective decision procedure. Specifically, we'll look at how we have to change our subject class in our premise diagrams in order to test for Aristotelian validity when we find that the argument is not valid in Boolean logic.